Good morning and we'll continue on our lesson. This is lesson number 3, Introduction to Composite Functions. We're going to just go straight to example number 1. The table below defines two functions. And then this one here is the function g of x. What we're going to do is, this is a little bit different compared to what we've been doing in a couple of days. This one is a composite. So the answer to the function will be used to figure out the answer to the next function. And that's what we're going to be trying to do. So looking at this one, when we have a composite function, the thing that we can do is that we can work from inside. There should be a brackets there. We're going to work on this inside or figure out g of 2. So if x is 2, what is the g of 2? So you're going to look over here in this table of value. When x is 2, the g of 2 is 1. So g of 2 is 1. So let's write that down. Of 1. So you're looking at the f function f, and it says x is 1, then the f of 1 is negative 1. So the answer going to this one over here, it says g of negative 1. Again, we're going to work on the inside first. So g of negative 1. So we're going to look at this table of values. So g 2 there. So g of 2. So the x value, that's how we can determine and evaluate the composite function using the tables. Now, let's go ahead equals to g of x. Determine the values requested below. Now, this part in here, we know that f of x is a linear function. F of x is a linear. F of x is a quadratic function. What we graph to figure out and evaluate the composite function. So starting off again from inside out. So f of 0. So f of 0. So the function f is positive 6. F of 0 is positive 6. So we're going to put 6 there. And then now we have to evaluate g. And then we look for 6 for x. Okay, so this is 6 g of 1. So we're going to look at the function g of 1. So function g is this quadratic function over here. And g of 1 looks like it's this whatever that value is. So this one here, as you can see, it's going to be a challenge without the equation. So what we're going to do is we can, so the linear function has rise over 1. So now with these two information, we can determine the equation of the linear function. That's y equals to negative 1/2 x plus 6. Negative 1/2 x plus 6. So that's that. What about the quadratic function? What's this quadratic function in here? Well, we know the basic quadratic function is y equals to x squared. Y is equals to x squared. But this is actually not y equals, it should be positive 1. If x is 2, it should be positive 4. If x is 3, it should be a positive 9. But it's not. It's not following pattern. So it looks like this graph is vertically compressed. Okay, but we don't know by how much. So we know that this is a vertically compressed graph. Let's see if we could figure out. Okay, I'm just going to pick a point that's easy, and it's going to be 2, 1. So I'm just going to pick 2, 1. So when x is 2, y is 1. When x is 2, y is 1. So I'm going to put that, okay? So this is going to be 1 equals to 4a, and then to solve for a, divide by 4, divide by 4. So that looks like, okay, this function g of x is really 1/4 x squared. So it's vertically compressed by a factor of 4. Okay, now that we have that information, what we could do is we can go, what's g of 1? Okay, g of 1, function g of x is equals to 1/4 x squared, and then 1. So I'm going to put in 1 wherever I find the g. So f of 1, so it's going to be 1/4 times 1 squared. Okay, so I'm going to use the function g, and then I'm going to replace it with 1 for wherever we find. Let's work this out. Writing on this function f, and if x is fourth to wherever we find the x, so it's negative 1/2 times 1/4 plus 6. So that's going to give us 5 and 7/8. 5 and 7/8. G of 1, we know it's going to be about a fourth. Right? It looks like one composite function using a table value. And then we looked at example number 2. That's the figuring out the composite function. This time they're giving us the equation. Okay, we have 2 equations in here. Determine the values requested. So m of h of 4. So we're going to work from inside out. So m, we're just going to copy m. And then we're going to use, and we're going to put 4. Okay, so x is 4. So we're going to put 4 wherever we find x there. This is going to be square root 4 plus 5. Okay, 4 plus 5 root of 9. Using the function m. But this time, we're going to replace the x by 3. We're going to replace x by 3 minus 1. That's going to give us 2. The answer to that is 4. That's our final answer. Okay. And m, they said x is going to use 13 wherever you find x. So h, m of 13 in there. So 13 minus 1 squared. 13 minus 1 squared. And 13 minus, simplify that, that's going to be 12 squared. 12, so there's the 44. Okay. So now that we've already evaluated the, we can now go ahead and do operate the function h, and h is 44 for x. Okay, so that's great. What have we done so far? All examples 1, example 2, and example 3 are all the composite functions. Now let's take a look at the last example. Determine an explicit equation for each requested composite function and state the domain of each composite function. So you might have to do this on a separate sheet of paper. Example number 4. Okay, example number 4. They said that f of x and g of x is equal of g of x. Okay, so what are we going to do? Well, we know what the g of x is. G of x is 3x minus 5. So let's just write that down. F of g of x is 3x minus 5. Attention to the value of, it says here, f of 3x minus 5. What they're saying is, this is your x value. This is what your x. I'm just going to put a little note. We're going to replace the x squared. We're going to replace x from f of x with 3x minus 5. We're going to replace it with 3x minus 5. So here we see x here, and we see an x right there. So minus 5. Okay. A little note here. I'm just going to do that. So 3x minus 5 squared. We're just going to clean it up so that we can simplify it further. So 3x minus 5, that's 9x squared minus 30x plus 25. And then now we're going to expand this one to minus 15. Okay. From here, we can collect like terms. So that's 9x squared. Next. And that's the explicit, this is the explicit quadratic function. So a combination will give us, now let's take a look at f of x. So the very first thing that we're going to do is we're going to write down f of x, okay, working from inside out. So write down f of x with plus 3x. Okay, right there, instead of x, and then minus 5. 3, and then the 3 is here. Okay, so you follow my fingers. So 3 and 3 are there. And instead of x, I'm going to put x squared plus 3x. So that's then right there. And then the minus 5. This is a quadratic. So that's done. To the very last one, letter C. Letter C. Okay. What's the letter C? It says here f of x. F of x. Let's go this way, sideways. I'm going to start with f of x with x squared plus 3x. Okay. How many places we have to replace the x? We have to replace the x. It's going to be times x. 3 times x is going to be, again, x. It looks like we might end up with a quartic function. So square this one, so that's going to be x to the 4th, and first term times so you would expand that, and then multiply plus 9. So there's a little bubble there. Simplify this part. Hold on. So x to the 4th. Okay. So x to the 4th, x cubed, and then the x squared would give us 12x squared, and then a 9x. Gave us a quartic. So what we're going to do is I'm going to stop right here. In this particular case, this is an optional thing in here of each function, of each composite function. Okay, let's just do that one first. X, we ended up getting a 9x and x. So this is the domain. Okay, now over here is g of f of x. We found that explicit equation would be 3x squared plus 9x minus 5. Again, that is a quadratic function, so that tells us that the domain is x as an element of real numbers, and then last but not the least, f of x. So that gave us a quartic, 6x cubed plus 12x squared plus 9x. So this is a quartic. Okay, so I'm gonna stop right there. Range from there. So you could do that, and certainly I'll just write it down in here. May use Desmos. Okay, you may use Desmos as a graphing tool to see what the graph looks like. This one, we know it's going to be questions for you to work on. Highly recommend those questions. Give them a try, and if there's